My name is Liam, and today I'm going to be talking about the internal gyro of the robot. Now, the internal gyro, also known as the internal motion unit, is a sensor from your robot that gives information about the direction the robot is pointing. Now, the gyro is pre-built into the robot's brick, so you can't see it, and it doesn't need to be plugged in, and it's always active. Now, how you see the information that it's giving back to the brick is by going up here and clicking on this green circle. Now you can see here there are these four numbers: yaw, pitch, and roll. Now these numbers are in degrees, which means that they're from a scale of 0 to 360, and they represent the direction the robot is pointing. Yaw is how much the robot has rotated, pitch is how far the robot has tilted forwards and backwards, and roll is how much the robot has tilted left and right. Now, because the playing field is largely flat, pitch and roll aren't very important. Yaw is what is important because what direction the robot is pointing is very important when you're navigating. Now, how to use yaw to let the robot navigate, I just have some example code right here. This does not use yaw yet. We will be adding yaw to improve its reliability. Now this code, what it does is it sets the motors up to move forwards, and it moves forwards for 3 seconds, and it stops moving, and then it moves right for 3 seconds. Now this is a good piece of movement code, but the issue is it doesn't consider other variables. It only moves at a set power and for a set time. But the thing is, there can be other effects that change how far the robot goes. For example, if the playing field is slightly sticky, let's say, then the robot will get slightly slowed down. The wheels will stick to the ground a bit. Maybe someone spilled maple syrup. I don't know. And that is an issue because the robot doesn't go as far. And it doesn't turn as far, which means it might miss its target or overshoot. And that means that you might lose points in the game, and that's bad. So how we fix this is we let the robot detect how far it has turned, which means that it doesn't matter if someone has uh, replaced the field with ice, or the robot is driving twice as fast as normal. As soon as the robot turns the distance that it wants to, it will stop. Now, how we do this is we replace this wait 3 seconds block with a different block, a different control block. We replace it with a wait until block. And then this wait until block, you can see it's the little it's the little hexagon, which means that we need a Boolean block. And we can go down into our operators and we can pick out this block with a little alligator face, and then this is going to be our comparison block to check to see how far the robot has gone. Now, to get a value that goes into the operator block, we need to go up to these blue blocks, and we can pick this circular one. Now, this circle means that it's a variable with a number in it. So we can see it right now, it's recording the pitch angle, but we can tell it to tell us the yaw. And then we place it in here, and now the robot is waiting until the yaw is less than 100. So let's change it. Let's say until the yaw is greater than 90, which means that when we run this code, the robot will move forwards for 3 seconds, and it'll stop moving, and it'll start turning to the right, and it will continue turning until the yaw is greater than 90. And remember, it starts at 0. So it starts at 0, it moves forwards, it's still at 0 because it hasn't turned, and it starts turning right. And it goes from 0 to 10 to 20 to 30, and it doesn't matter. If I put my hand on it, it stays stuck at 30 for like a few seconds, straining against my hand. I let go of it, now it's at 40, 50, 60, 70, 80, and it hits 90, and it stops. And it doesn't go past 90 because it's stopped moving. And that is how you can use the internal gyro to make sure that your robot turns the right distance every single time. And it's very useful for making your programs as accurate as possible to score as many points. And I find it one of the most fun things about programming. And I hope that this video was helpful, and I look forward to seeing what all the creative things you can do with the internal motion unit will be. Thanks.